The datasets we use traditionally include two things. The first are observations, or sometimes called instances. These could include all of the students taking a test, all of the respondents to a survey, or all the participants in a study, for example. The second are all the variables associated with those observations. So for an example, we could have the age of the participants, the gender of the participants, or each individual response to a test or survey item. In R, the data frame is the type of data type that allows us to handle this type of information. Conceptually, a data frame is comparable to an Excel worksheet, where we have rows and columns. Each of the rows represent the observations, and each of the columns represent the variables related to those observations. In R, we can think of each column as a vector that holds the information for each variable. For instance, all of the names of the participants, all of the ages for each of the participants, all of the gender information for each of the participants. So we notice here that in working with a data frame, each vector should contain the same amount of elements, and those elements should equal the number of participants in our study. As we've seen previously in working with vectors, the elements of each individual vector should be of the same atomic object class. However, in a data frame, we can have vectors of different atomic class types. So for instance, we could have numeric vectors, we can have character vectors, we could have logical vectors, all within the same data frame. Okay, so let's build a data frame in R. We're going to conduct a research study, and let's say we're interested in understanding parents' perceptions of the effects of private music lessons on children's goal orientation. So we decide we're going to distribute a survey to parents of students who are participating in private music lessons. So in this case, the survey would consist of 4 items, each of them representing the construct of goal orientation. We would provide 4 statements, and then the response would be a 4-point Likert scale: strongly disagree, disagree, agree, strongly agree. So in this study, we're going to collect information on the children. We want to know their age, we want to know the amount of years that they've been taking lessons, and then we want to collect the responses from the parents of each of the 4 items. So how do we put this into R? So first, let's think about the vectors that we need to create. First, we want to create an anonymous ID for each of the parents, so that would be one vector. A vector for the age of the children, which would be our second vector. We want to create a vector that represents the amount of years that the children have been taking private lessons. That would be our third vector. And then we want to create an individual vector for each item response. So in total, we're going to have 7 vectors. And for the sake of this study, let's just say that we had 5 parents respond to our survey. So the first vector that we need to create is the ID vector. So we'll just call it ID, and we'll concatenate 5 integer IDs. So a quick shortcut for entering sequential integer data, instead of just typing 1, 2, 3, 4, 5, which would come back as a numeric vector, we can just type 1, semicolon, 5, and that'll give us all the integers between 1 and 5, including 1 and 5. So I'll just run that code. Now we have an ID vector that's integers 1 through 5. Okay, let's create a age vector. So we'll call it age, we'll concatenate it, and we had 5 respondents, so let's just say that the ages were 12, 15, 13, 8, and 10. I'll run that code. Now we have the age vector that's numeric with 5 elements. So as we're doing this, we're always checking here that we have the right class of vector. So numeric is correct for an age variable, and we have the same amount of elements for each vector. Okay, now we can create our years participating vector. We'll call it participating, and we'll concatenate it, and we'll say that the years are 2, 3, 1, 5, 3. We'll run the code, and once again, we have a numeric vector with 5 elements. Okay, now we've gotten to our 4 items. So once again, thinking about the concept of a data frame and how it might look in an Excel data sheet, each respondent ID has its own column, the age of the respondents has its own column, the years of participating has its own column, and then each response to each item will also have its own column. So to think about this a little bit more realistically, let's say item 1 is the prompt: my child finishes tasks on time. Let's say item 2 is my child concentrates on learning. Let's say item 3 is my child motivates themselves to complete tasks. And then let's say item 4 is my child prefers work that is challenging in order to learn new things. Okay, so let's come up here and code item 1. We'll call this object item 1. And let's say the responses that came back were 1, 3, 4, 2, 3. We'll put that into our workspace. Okay, we'll say item 2, and the responses that came back for item 2 were 4, 1, 2, 3, 1. We'll put that into our workspace. Let's say item 3. The responses came back as 2, 4, 3, 4, 1. We'll put that in our workspace. And then our last item, 4, we'll say those responses came back as 4, 2, 3, 1, 2. And we'll put that in our workspace. So we'll notice here in our workspace, we have 4 items. They came back as numeric vectors. Each of them have 5 elements, which represents the 5 responses. So in the spirit of being complete with our work, we've coded the items, but they're still currently numeric vectors. Anytime we're working with Likert type items, there's 3 important steps we need to go through with the items. First, we need to do an explicit coercion of taking that numerical vector and turning it into a factor vector. Then we need to assign the labels to each of the levels. And lastly, we need to assign order to those levels. So I'm going to come down here and type a comment, and the first thing that we need to do is an explicit coercion. We need to coerce all of the numerical vectors related to the items and change them into factor vectors. So I'll name this first object item1 factor. We'll use the asFactor function, and then we'll pass through it the item1 vector. I'll put that into our workspace, and now we have a factor vector with 4 levels. Okay, so what we can just do is we can copy and paste each of these, and then we can change it for items 2, 3, and 4. Okay, we'll run each of these as well, and we'll get them into our workspace. Now we have all of the items assigned to factor vectors. Okay, so the next thing we need to do now is we need to assign labels to levels. So let's work on item 1 first. We'll use the item1 factor vector, and then we'll change the object name to named. Then we'll use the factor function. And inside the factor function, first thing we'll pull in is the factor vector from item 1. Separate it with a comma, and then the second argument is we'll concatenate the labels. Okay, we'll run this code to make sure it works. Item1 factor named, and now we have the labels assigned to the 4 factor levels. And the same thing that we did before, we could just copy this, and we can just change the item names. We'll run each of these as well and get them in the workspace, and we're good to go. And the last thing that we need to do is assign order to the levels. I'll bring this down a little bit. Okay, so let's create a new object. And we'll just tag on ordered to the object. We'll use the factor function one more time. We'll bring the vector that we're working on, which is the named vector. And then we'll add ordered equals true. Let's run this code to make sure it works. Great. And now, same thing. We could just copy and paste. Okay, we'll run these and get into the workspace. And then we're all set. So now that we put all the work in to properly prepare the data, now we're ready to build the data frame. So I'm going to add some lines here so that way we have some extra space to work with. And I'll write the comment, build data frame. So just like the vectors, a data frame is also assigned to an object. So we need to give the object a name. So because we're working with goal orientation, why don't we call the object goal orientation? And now we need to assign to the object a data frame. So in order to do that, we can use data.frame as the function. And for the argument, all we do is provide a list of all the vectors that we want to put into the data frame. So in this particular instance, we want to add ID, we want to add age, we want to add participating, and then we want to add the ordered factor vectors. We'll run the code. And then we notice up here, instead of values, we have a new category called data. The data frame is called goal orientation. It has 5 observations. And then inside we have 7 variables or 7 vectors. So in order to check this, we could do two different things. The first thing we could do is just type in the data frame. We'll run the code. We'll see here that it looks like an Excel spreadsheet. So we have the ID of all the respondents, we have the age of all the respondents, we have the years participating of all the respondents, and we have the responses for item 1, item 2, item 3, and item 4. Additionally, what we can also do, if you see in the top, there's a blue arrow. So what we can do is click on this, and that way it'll open it up a little bit so that way we can see the structure of the data frame. We can also just click on the title of the data frame, and you notice here it's going to open up a new tab, and it's going to look a lot more user-friendly, much more like an Excel datasheet. One last thing that we can do to clean up the data frame is we can explicitly assign names of the columns to the data frame. So right now the names of the columns are the vectors that we created. However, item 1, factor, named, ordered starts to get a little sloppy when we're working with the data frame. So what we could do is we could just bring those back and call them item 1, item 2, item 3, and item 4. So let me write a new comment indicating that we're just going to name the columns. So in order to do that, we can use the names function. And inside we can pass the argument of the data frame. And then we'll concatenate the names that we want for the columns. In this case, we have ID. Our second column would be age. Our third column, we can call it years participating, just to be a little cleaner. And then we could do item 1, item 2, item 3, item 4. We can run that code. And now in the console, I'll just call in the data frame. Take a look at it. And we can see here that the names of the columns have now changed and it's a little bit cleaner. Also, what I can do is I can come over here and I can just click on the title. And that's going to open up a new tab. And now we have the new item names here, which is a lot cleaner. Also notice that instead of clicking on this tab, if we want to be more clear and put into our code that that's how we checked it, we can come down into the console, or we could even put this in the code and we can use the view function, and then as the argument, we can just pass in the data frame. And now we have a clean data frame to do some analyses on.